Depreciation is what? What's the simple definition of depreciation? It's like it's a loss in value. Is a loss in value, usually of an asset. Okay? So depreciation is the loss in value. Now, there are two terms that you need to know when it comes to the depreciation. The first one is the book value. The book value is the value of an asset or equipment after considering the, or after taking depreciation into account. So the book value is the value of equipment at a given time after depreciation has taken place. Like example, if you buy a car now, okay, next year, if you want to know the value of the car next year, whatever that value is going to be, it's going to be the book value. Because a car loses its value. Okay? Usually houses don't lose value, but cars do. Okay, houses can, but in most cases they can appreciate. It will depend with the economic situation. But in most cases, in all cases, cars lose value because they get old. Then the scrap value now, it is actually the book value of an asset or equipment at the end of their useful life. So before you maybe say you want to throw away the car, you want to take it to the scrap yard, you can determine the cost of that car or the value of that car. That value is called the scrap value, which means the asset, this word scrap here means it's no longer it's becoming useless. Right? With book value, it will still be useful, but with scrap value now, it becomes useless. So you probably want to throw it away, maybe take it to the dump or take it to the scrap heap. Right? Now, there are two types of depreciation. There is linear depreciation, which comes from the simple interest formula. And then there is what is called reducing balance depreciation, which comes from the compound interest formula. So this one here, it comes from simple interest formula. And this one here is compound interest. Right? So let me move on to the next page now. I'll introduce the formula for those two. All right. So let's start with linear depreciation. Now, linear depreciation is really the simple interest formula, right? So the formula for linear depreciation is also called straight line depreciation. Remember, the word linear and straight line, they are synonymous. So the formula for linear depreciation is this one, right? The formula is A equal to P times 1 minus I times N. This minus here is the one which tells you that there is what? Depreciation. That minus, right? Everything else, in terms of the definition, is the same as how I defined last time. But here we can go further and say A is going to become the book value or the scrap value, which means A is going to be less than P. P is the present value, and I is the depreciation rate, N is the time period. Okay? Now, don't confuse this formula in the one for appreciation, the one with the plus. Right? Depending on the situation, you need to read the question carefully and determine whether does it involve depreciation or not. If it doesn't involve depreciation, use the formula with the plus. If it involves depreciation, then use this formula with the minus. So be very careful. Whenever you see a question now in metric, don't rush to use the formula with the plus if it involves a bit of some depreciation. And you need to know whether is it linear or is it uh, the reducing balance formula. You also need to know. Right, so the reducing balance formula is related to the compound interest formula, right? The formula is a minus as well, so it's A equal to P times 1 minus I raised to the power of N. Again, be careful of that. The clue usually when you get a question on this formula here, it will tell you that according to a reducing balance depreciation. So you have to memorize that if it's reducing balance depreciation, then you use the formula for compound interest with a minus. So again here, A is the step value, P is the present value, I is the depreciation rate, and N is the time period.
So you're not changing much, you're just changing the plus and minus.
Yeah, because of the depreciation and appreciation. Right, so make sure you are aware. So what that means is up to this stage, we now have 4 formulas. 2 that are related to simple interest, which is linear, and then 2 that are related to compound interest, which is exponential. Okay? Then let's do an example. So let's start with part A. The question says Nelson buys a motor car for 160,000, right? The car depreciates. So this is gonna be your P. The car depreciates at a rate of 11% per annum. What is the car worth after 6 years? If depreciation is calculated using straight line method, that's the simple interest formula. This is depreciation now. So we say we list whatever information we have got. Our A here, we don't know. P is 160,000, right? N here is 6 years. And our interest rate is 11%, or rather we can say the depreciation rate is 11%, which if I want I can convert to a decimal, but I can write it like that. But this will be 11 over 100, because if I write I must write it as a decimal. So our formula is A equal to P times 1 minus I times N. And here we have got 160,000 times 1 minus I, which is 0.11, times N, which will be a 6.
Yeah, that one.
What answer do you
7, 9, wait. Yeah, 79517, comma 07. No. Yeah, it is. I got 54,000. So you put the percent sign on the calculator.
get? Okay, if you don't put the percent, just put 0.11 times 6.
What if you need it?
Are you getting this answer?
Yeah. Sure. Yes, put the percent sign. I put over 100.
You can't put the percent, you put it over.
You can put the percent sign.
Oh, you need compound interest.
Yeah.
No, it's simple interest. If you are just the P, you got simple interest.
Oh, okay, sorry.
Well, it's straight line depreciation.
Sorry.
Yeah, it's 54,400.
And then
54,400. Any cents? No, just do the whole number. There are no cents. Okay, you give your answer.
yeah, then this answer the same 79517.
Yeah. Fine. Alright. And then B. The reducing balance formula, we are going to use the same information. So it is A equal to P times 1 minus I raised to the power of N. Right. P is 160,000 times 1 minus I, that's 0.11, raised to the power of N, which is 6 years. What answer do you get? You are done.
795.
Two decimal places. Finance, you round off to 2 decimal places. So don't forget that this is finance. So you round off to 2 decimal places. Alright. Okay, so we have got that. Then, second example. The office computers for a small business are currently 40,000, right? Calculate the value of these computers after 6 years if the rate of depreciation is 16% and calculate on a linear basis. Please take note, if it says linear basis, right, use the simple interest formula with the minus. Right? Now, this is very important for you. Whenever you see a question now in financial math, you need to read the question, understand the question. It's very common to use an incorrect formula. It's very, very common. You can use the formula for simple interest where you're supposed to use the one for compound interest and vice versa. Right? So, we don't know what A is. Our P is 40,000, right? N is 6 years, and the depreciation rate is 16%. So I is going to be 16% over 100, which is 0.16. In my case, I prefer to work with I. Okay, prefer to work with I. So since it's a linear basis, and there's depreciation involved, so A is going to be equal to P times 1 minus I times N. I'm using the simple interest formula which involves depreciation because the way it says linear basis. This equation here, it's a linear equation. This equation here. It's of the form y equal to mx plus c. If you remove the brackets, right, your two variables will be the a and the n. N is time. Okay? This I here will be like a gradient and the p will be like the y-intercept. Right? So P is 40,000 times 1 minus I, which is 0.16 times N, which is 6 years in this case. So what will be the final answer? 1,600. Will be 1,600. Those computers, they will be decreased in value after 6 years. Not of fact, they will be outdated. All right.